name is Daniel Tay, and I am presenting this presentation on behalf of our team, which consists of Mei Hui Lee, and this is our time series analysis final project presentation. So the data we've chosen comes from the ABS, and we've chosen to select the sale of sports utility vehicles, or SUVs, sold from 1994 to 2017. Now, a bit of background on the sports utility vehicles and sort of cars in Australia. In the 90s, the most popular car was the sedan model or the passenger car, but in the last 5 to 10 years or so, there's an increase in popularity in sports utility vehicles. So our goal is to analyze this trend and to see whether we can forecast and predict what will happen to SUV sales in the next 3 years. So we begin by plotting out our data set time series. And from this time series, you can see there's a bit of an upward trend. Well, not just a bit, there's an upward trend. And no obvious seasonality, but we could see a possible change in variance and a change intervention point somewhere in 2010, 2012, where there's a bit of a spike here. And therefore, this data set does not look like it's a stationary data set. So why does it have to be stationary? It's because if we want to do our ARIMA modeling, we need to make sure that our data set is stationary. So we first observe and perform some tests by using plotting out the ACF and PACF score, PACF and PACF plots. And you can see from our ACF plots, we have an obvious trend over here, and it's a decaying trend. This decaying part of the ACF would indicate this trend, and this spike as well in the PACF, the first big huge spike, would also indicate trend and also indicate that our data is not stationary. When we statistically test this with the ADF test, you can see that our p-value is 0.96, which is more than 0.05, thus it's not stationary. And when we test for normality, you can see that our score is less than 0.05, indicating that our data set's not normal. So our next step in order for us to do any ARIMA modeling is to make sure that our data set's stationary. So our first thing that we did was try to differentiate and make it stationary via differencing. So after taking the first difference, we plotted out the graph again, and you can see over here that there's a lot of change, and you can see that it looks more stationary. There's no more trend. There are a couple of few odd spikes, but overall, from observing visually, you could conclude that this is a stationary data set. Now, to test that out statistically, and that backs up what we think it looks like, and you can see we have now an ADF p-value of less than 0.05, and therefore, statistically, we can now confirm that we have a data set that's stationary. So our next step was to look at model specification and see which models that we could use. So we did this using the ACF and partial ACFs. Plots first, you can see on the fifth lag on both, there's a spike, so we could use AR5 and MA5. From our EACF model, we looked like we could use AR1 and ARMA4. Big table is just showing just a test lag of 5, which we'd already covered in the other diagnosis. So our possible models from our ACF, PACF, EACF, and BIC analyses are ARIMA 515, ARIMA 511, ARIMA 414. So our next step was to look at the AIC and BIC scores for all the 3 models and sort of sort them and rank them to see which possible models that we could use. So when we rank them, AIC score 414 was the top model, and for the BIC score, 511 was the top model. So in order to sort of proceed, what we did was we decided to look at both these models and perform our residual diagnosis and analysis on it, and assess from there and see which model we could sort of lean on and choose. So when we look at our the first one is the results from the 414 model. You can see over here we have a bit of an issue of a normality where at the end and from the start of the QQ plot and the end of the QQ plot sort of drifts away from normality here. But if you look at our Lung box test score, we could see that all our values are above the red line, which indicates it's all more than our p-value of 0.05. When we look at the model 511, similar QQ plot residual results, does drift pretty significantly from normality here, and maybe a little bit at the beginning here. And we also have a worse off Lungbox score where we have the dots closer to the red line or 0.05. So what we conclude is it looks like our 414 model was the better model, but we did forecast for both and model fit just to see what our results would possibly be. This would be results for 511 and 414. Now, our next step for our assignment would be to assess whether we can do any transformation on our data to get better results. So we're going to look into the Box-Cox transformation and also just whether we can do it by log. And hopefully in our final result, we will reassess our models again and to give the final verdict. Thank you for listening to me, and this is the end of my presentation. Thank you very much.